problems in like recognizing some code parts or data parts, and it makes a lot of false positives. And as I said, security implication score is a signature-based scoring system. So something like a string length, you can use string length to like patch some kind of Stack Overflow. So you should use string length to fix that kind of problem. So it should appear in the patched part. So how about the safe string API? So something like Microsoft SDL, like they recommend using like a new API, new safe string related API. So in that case, they should use a safe string API to fix the old problem. So you will find that like safe string API from the patched part. So you can use that for like signatures for locating security related patches, or about some like a constant numbers, some big numbers, maybe to fix some integer overflows. So this code is written in Python, and it's in Python, so you can just rewrite the part. If you have your own logic, so you can just rewrite the part and you can test it yourself. So the actual question will be, is it working or not? So I have an example here, like acroaudi32.dll from Adobe, and they patched, they released 9.3.3 recently, a few months ago, and I diffed 9.3.3 with 9.3.2, and it created like a 3,630 entries, like modified functions. So it's almost impossible to go through every functions to find these security patches. So if you use SIS, the security implication score here, then if the entries with number 0, the score 0 is only 692. And the score more than 1 was only 70. So you can like save a lot of time and effort here. So I will show you DarunGrim, how DarunGrim 3 looks like. Okay. So this is the main page. Actually, I'm running some background like a web server, just like a Metasploit. They use some web server to like run some their own process or something like that. So I just use web, what is that? The other one is CherryPy. I just use the CherryPy Python module to run the web server, and you just connect to like a local host. You can like designate like any port you like using like a configuration file. So in this case, it's 80. So you just connect to like a local host like this, and it's just main menu. And it only has 4 menus here. And if you click here, yeah, files import. And there are some input box here. So here, you don't have any files yet, right? So you need to like import all the files from like a remote machine or your local machine. So if you want to collect some, because I'm running Windows XP right now, if you want to like collect all the Windows XP system files, you just put like a C Windows here, or maybe you can use C program files, anything like that. Then it will collect like copy all the files to your like library. So you probably need a lot of hard disk, like 20 or 30 gigs storage space for that. And or maybe you can set up some virtual machine and you just install something there, and you can just like share some directory there and something like this, or you can just import all the files from the remote machine. And in that way you can collect all the files and binaries from other machines, or for like other operating systems. So it takes some time, like 20 or 30 minutes. And after that, if you click Files List, the system will parse all the information from the like binaries and version from the files version information, and it will like sort all the files like according to their company names and like file names and everything like that. So here's all the company names that are installing the binaries on my system. So probably you might be interested in Microsoft Corporation. So click here, and it will show every file from Microsoft Corporation. So I used an example from like a NetAPI 32. This is a kind of a RPC DLL that is exposed through the pipe. So it has some history of a lot of vulnerabilities found from 5 years ago or 6 years ago. So we are interested in that file. So we just find the file here, and you go there, and actually it will show every file that has that name. So here you have all the file netapi32.dll with that name with different versions. So you can see, so maybe you can just want to diff the latest one with the previous one, like a 5.2605.694 with the previous version, like a 3462. You just click it. The left one here is the previous file, and this one is the a patched file. So you just click start diffing here. It takes some time, like 5 minutes or something, because it will launch IDA. You need actually IDA. Like IDA, I used IDA 5.6. So probably if you are like a reverse engineering guy, you probably have IDA. So you can use IDA, and it will locate the IDA, and it will launch the IDA and generate all the information and gather all the information for you. So after that, the result, it will take 5 minutes. So I just created some examples here. So in this case, it is one of the examples. So after that, it will generate some table like this. So you can see there were only 2 patched functions, and you see that there are security implication score here, 3 and 2, and probably 3 is bigger. So probably this function has some patches inside it. So if you click it, then it will shows some tables like this. So from the table, the left side, actually left side empty, right? So actually the start is here. So left side is unpatched file, and right side is patched file. So it means that the red block, it means that the red block has been inserted to new the patch. So it means that can you see this? Actually it's calling WCSLAN here. I'm not so sure you guys can see this. It's a WCSLAN here. So actually the patch is patching the vulnerability using calling WCSLAN. So you can actually see what the actual programmer did to fix that vulnerability. So it had Stack Overflow, and they fixed it by just calling WCSLAN from the start of the function. So this is some table view here. So this is left side. If something happens in left side, it means that they removed that code block. And something happens on right side, it means that they inserted new blocks there. So you just need to look into red block, or there are also yellow blocks, but there are no yellow blocks here. So yellow block means the block has been modified. So maybe I can find some example here. Yeah, there are some yellow blocks here. So in this case, it changes some logic here, so it's recognized as a kind of red block. So anyway, so you can click Open IDA menu here. So you can actually use IDA to see the diff result. So in that case, this is the old binary for same function. So it's a NetP manage IPC connect here, right? And if you see the graph overview, it doesn't have many things here. And there are some red blocks here. So it looks like they removed this block from the unpatched binary. So it shows two IDA. The next one is patched binary. So you can see that they inserted new blocks here. And because it's showing the red block here, right? So it means that they inserted new blocks like this one, and just 3. And the first one contains that call like a WCS LAN. So actually you can use IDA to perform the actual analysis because it's more comfortable to the reverse engineers. So this is the demo. Oh, not this one. 25. So let me show you some signature examples here. So I just talked about the signatures, right? So it's all about the signatures. So what kind of signature are you talking about? I just talked about string lengths or some constant number like a 0x, FFF, something like that. But beyond that, what kind of signature can you use? So this one is MS06070. And you can see that the vulnerability is in here, SWPrintf here, right side, right? SWPrintf is accepting some data from ARG0, and actually this function is exposed through RPC interface, so the user can control ARG0, and it can just direct straightforward Stack Overflow. In that case, this is the example that I just showed. NAPI manage IPC connect, and just as you see, it's using WCS LAN to fix the problem. And you can know that you can use a string length or WCS LAN or that kind of string length check as the signature for both Overflow. So what about the other like a Stack Overflow, like MS08067? This was used for config.com, right? So it has 3 entries here, and the first one has a security implication score 20. And you see that, I'm not so sure you can see that, but this is a string CCH copy W API. This is a new API introduced by Microsoft. So it's a safe string like API or something like that. So whenever they Microsoft patches any string-related problems, they are going to use these new secure APIs. And we can use that as a kind of pattern to locate the security patches. And this is integer overflow from MS10030. And it is the problem inside the Microsoft Outlook client. And if you use DarunGrim, you can see that I sorted by security implication score here, and you can see that the first entry is like a response start method from cpop transport. Looks like it's processing some response from POP3 server. So if you look into that, you can see very interesting call inside it. Actually, I'm not so sure you can see this. It's API ulong long to ulong. So it's an API that converts 64-bit integer to 32-bit integer. So you might wonder, the original problem was integer overflow, and they are using 64-bit to 32-bit conversion API to fix integer overflow. So you might wonder why it is working. So before that, if you track the input for the conversion, it's coming from actually string to int API, and the buffer for a STL to int API is coming from a POP3 response, a header, a response line. So it's like attacker controllable. If the attacker is running some fake a POP3 server and hijacking some wireless traffic or something like that, then maybe